First of all, again, thank you very much, Jousef, for having me here. I'm really happy to share um, new, options and opportunities in the domain of reinforcement learning. 2 days ago, in the introduction to reinforcement learning talk that we had here in the Science Circle, we have been talking about what is reinforcement learning, the most important things to know about it, like definitions, solving methods, problems that he has. And of course, it's just a start because it's a very important, complex and also big problem or subject in general. So I also shared different type of resources that someone can use to learn more. I also shared the PDF of the previous slides, previous talk slides. So I think Jousef, if it is not already there, we'll share the presentation with all the participants. Now, having said that, today we are going to focus on a very practical topic. So we will use DIAMBRA Arena, that is our own suite of reinforcement learning environments to learn how to deal with RL. We will start by taking a look at how to interact with the standard reinforcement learning environment. And then we will interface the environment with a state-of-the-art reinforcement learning library that will be stable baselines. And we will see how to incrementally build training script that is able to, reach a very good performances in this environment. At the very end, hopefully we will, make it on time. I will show you one agent, the execution of one trained agent on one of these games, just to give you an idea of what it means training something and how it looks like having a trained agent there. So okay, let's get started right away. Now, the most important things here, I'll try to go at a good pace. So hopefully you should be able to read what I code in my screen. It's pretty big, the font I'm using here. I will just, build the script and use the terminal. I will do everything on the terminal just to make things quicker. So the first thing I want to share is how to install our suite of environments. It's very easy. You can go on our documentation page. You can access this in many different ways, but the URL is docs.diambra.ai. And when you arrive there in the homepage, there is the installation section, and it's very easy. So the first thing you have to do is to create an account on our website. It's completely free, and you can just go there and register here. As you can see, username and password, and that's it. Look into the spam folder in case you don't receive the activation email. So after that, you just need to install Docker on your system, either Linux, Windows, or Mac. I will be using Linux. It's the, I cannot lie here, is the one that is better supported at the moment. Everything can run in every single OS, but in Linux, you have more flexibility. I will use that one. If you use Docker on Linux, make sure you add your own user to the, you give permission to it in order to, allow the Docker to run, because some authorization is needed in this regard. So create an account, install Docker, and then just two simple commands. One that installs our command line interface, and the other one that installs the DIAMBRA Arena. Now, as you will see here, installing the command line interface is suggested to be done at system level, so not inside a virtual environment. But for my case today, I will install it in our virtual environment, my virtual environment. But it works in the very same way. And then, create your virtual environment to isolate all the installation for Python and install the DIAMBRA Arena. Now, let me just do that. As you can see, the first thing I want to do is create my own virtual environment. As I said, I already have Docker. I already have my profile on the DIAMBRA, of course. And so I create here an environment with Conda that is I call it the DIAMBRA Arena SB3 because we are going to use stable baselines 3. I'm also specifying Python 3.8 because for many different reasons, 3.7 is going to be deprecated soon, so it's good to have it. You should work also with 3.7. Dependencies can be a little bit tricky to fix, but in general, with 3.8, you are sure it works with 3.9 too. So I'm using 3.8. Let me create the environment here, and just, it will install the few standard packages there real quick. And this is one thing. And when the environment is created, I just activate it. And when this is active, now I will simply copy the commands. The first one is Python 3 install DIAMBRA, and this will install here DIAMBRA command line interface. The command line interface is an helper binary that helps us and managing multiple things of the environment, and it will be more clear in a few moments, but it's just an helper binary. And the main code here is in the command pip install DIAMBRA Arena. This will install all the dependencies required by the environment, and that is done. When you do this, you are ready to run the environment in your own machine. Okay, this is all what it takes to have the environment available in your machine. In fact, when this is done, I will just create a script, and we will see in code the standard reinforcement learning loop that sees the agent and the environment iterating. So this is almost done. And when I will have the prompt ready, I will show you, I will start coding the first very simple interaction. Okay, here we are. Now, I will use Vim, but of course, so this is gonna, I call it gist.py, and this is the very starting, let's say, code script that helps us run in the environment. So as you will see, after the installation, you need to do just a few more things. Now, the first one is you want to have game ROMs are not provided. As you can imagine, there are a little bit of, license things to be handled. But if you need to have guidance regarding which games are available and where to get the ROMs, well, you just need to do the following. DIAMBRA. This is the command line binary, and as you can see, Arena list ROMs. This provides a long list of games that you can just scroll down, and for each game you have like the sum, just the checksum listed here that makes sure that you will download the correct zip file. The search keywords, if you just copy and paste these keywords on Google, you will have, very likely the first link will be the correct one. When you download the zip file from there, and I already have them, of course, in my ROMs folder, you can check if this file is the correct one. Now I have it in my folder that is the following. Here it is. This is my folder. Now, as you can see, I have an environment variable where I stored the path where I have my ROMs. And this is good because otherwise you will need to specify this path, so the ROMs path, every time. Instead of doing that, the suggestion here is to set an environment variable that contains that path. Okay, you can call it, this is the main the main thing to do. And so I do have all my ROMs there. If I want to check if the ROM downloaded is correct, I just need to type the following: DIAMBRA arena check ROMs, and then the path to the ROM file, that is the following. In my case, I'm verifying Dead or Alive, and as you can see, the answer is correct ROM file found for Dead or Alive with the checksum printed out. Okay, so again, you install the package via pip, then you download the ROMs that you can easily find in the way I showed you, and then you check if the ROM files are correct. At that point, you are ready to write your script. Now let's do that together very easily. So the script will be, let's say, gist.py. Okay, as you can see, first thing to do, import the package. Then you create the environment. And this is very easy. You can just call the make function, specifying the game identifier. Now, on the website, on the documentation, you have all the details regarding all this stuff. For example, if you click on environments and then you click on games, you have all the games available. And for each of them, for example, Dead or Alive, there is the specific game ID that you need to use, plus additional info. As you can see, the search keywords, the checksum, and so on. For each game, you have a different ID that you can specify. In our case, let's start with Dead or Alive. We can modify that later. Now, remember the interaction loop we have. The first things we need to do is to reset the environment. And so the first thing, and the reset method, this is a standard OpenAI Gym interface for interacting with the reinforcement learning environment. And so the first thing to do is to reset the environment, and this will bring the agent to the first situation in the game. I mean, for fighting games, this will bring us to the very beginning of a round. So after that, you start the interaction loop. And as you can see here, we just use a while through. And the first things we are going to do, we are going to render the environment. And to do that, there is a method called render that shows a very small, a very quick image that presents you with the frame in which you are, is represented the state of the game. After rendering, the next thing is to select an action. So in this case, we would like to start using a random agent. And to do that, we can just sample randomly from the action space. So we do have access to the action space of the environment, that is this one, and dot action space. And we can just sample from it to obtain the action, a random action. Then we send the action to the environment. Now, the environment will return the observation, reward, done condition, and some additional info. This is the step of the environment. The step method receives an action and returns the observation, the reward, the done condition, and some info. This is the standard interface for OpenAI Gym. At the end, we just check if we are in a terminal state. So if done is true, let me spell it out. If done is true, it means we are in a terminal state. At that point, we will need just to reset the environment. And maybe if we want to do just a single episode, break the while loop. This, and at the end, we've just closed the environment. Okay, that's it. This is all what it takes to interact with the environment in a random way. Now, to run this, as you can see, the documentation tells you that you just need to use the CLI, the command line interface, DIAMBRA run. You have to prescribe the path to your ROMs, as you can see with this -r with -r option. But if you have the environment variable set to the DIAMBRA ROMs path, as I have, you can omit that and just run Python script following the DIAMBRA run. So let me show you what happens. So if I just say DIAMBRA run Python gist, that's it. This should, because of course we are alive, this should start the environment and run the random agent. So we'll take a look at it very quickly. As you can see, the first run asks for your credential. And then these are the credentials you use to register on our web platform. And then it starts the interface. Everything works. These are just login messages. This is the agent is getting ready. So the environment is being prepared. A recap of all the settings, and we will deep dive into them in a moment. And this is just a random. You see, we are using, in this case, we are using a random character, in particular a redo, the one on the right. Now let me try to. I'm not sure if I can. Oh, okay, yes. So we are using this guy. As you can see, redo is performing random random moves, and as a random agent. And sometimes it wins, but sometimes it doesn't. As you can see now, we are 1-1. This is a difficulty level that it's a medium. Sometimes random agents are able to win some rounds, and this is normal. Actually, it is how they learn how to behave. But so far, this agent is not learning anything. Now, as you can see, this is going at not a normal speed. We will have access to different settings to allow normal speed execution. As you can see here at second stage, our opponent is beating us. Actually, this is done. You see the episode is done. In fact, we lost both rounds and the game is restarting. And so since we just asked for a single episode, everything has been completed. Okay, so this very simple script performed, instantiated Dead or Alive, resetted the environment, and then started an interaction loop. Okay, this is how you interact with the environment. Now, let's start digging a little bit into multiple aspects. One thing is all these environments have multiple settings available. To understand how they work, you have information here. For example, there are, for the environments, there are settings description telling you different settings, how they control the environment execution. But even more, you have examples. There are examples that you find on our repository on GitHub. And for example, there are single player environment examples, multiplayer environment, wrappers, and so on and so forth. So for now, let me just open a single player example. And as you can see, we can access them directly from the GitHub. Let me open the GitHub. So the repository of Arena, and in particular examples. So the single player example is this one. Now let me just copy and paste it and we can go through it very quickly. So let me just, I can just download it, but single player, let me just copy and paste it. Okay, so let's go it by, by line by line. As you can see, first we import the DIAMBRA arena, and then from the DIAMBRA arena utils, we import the so-called show gym observation. Now, this is a functionality that we will use to print out the observations we are collecting from the environment. And here we are defining settings. First setting I'm talking here is the player, so-called player. For example, here we can prescribe if we want to play on side of P1 or on P2, so starting on the left or on the right. Or you can prescribe a random value here, meaning that 50% of the time you'll be on the left and 50% of the time you'll be on the right. Now, this parameter here, step ratio, rules, it tells you if how many steps of the game you want to run per each step of your environment. So it means that for every step of our while loop, we can run, in this case, 6 step of the game. This is useful because sometimes the game is, it goes at 60 frames per second. So if you just use a 1 here, it could be too low. So a little, not so informative in terms of what is happening in the environment. So 6 can be a good starting value in general, but you can play around with these settings. Then there are others like the frame shape. We asked it for in the previous one. We were just using the native resolution of the game. For example, here we are prescribing we want a 128 times 128 RGB frame. So we are resizing the native resolution to a smaller 128 times 128. Here you can prescribe if at the end of the round, at the end of the game, in case you hit a game over condition, you want to continue it or not. You can prescribe different values. Everything is on the documentation. One thing that is worth mentioning right now is, for example, the hardcore setting. The hardcore setting is something that tells you if you want to use as observations only the frame or also numerical values. In this case, it's false. And when it's false, you are using both the screen pixels together with numerical values. Here you can set the difficulty level of the game. You can select the character you want to use. The action space, if discrete or multi-discrete, you will remember from previous RL talk that there are different options available. And yes, that's it. As you can see, we just create the environment in the same way using make. And together with the game ID, we also pass here the settings. That's it. After you build the dictionary in Python, you just add it here and you have the very same interaction, as you can see. Now let's take a look at it. And as you can see, we will be printing out observation after the reset and after each step of the environment. Let's see what it looks like. So I just need to run DIAMBRA, Python single player. This should run, of course, I messed it up with typing. This just, runs the single player script that I was showing you, and with all those specific parameters I showed you. Now, let's see. There will be a resized frame, 128 and 128, as you can see here. There will be, we will tweak these settings a little bit together. As you can see, the frame is smaller. In fact, we are using a smaller frame here. Now, another thing that you can see, we are printing out observations on the screen, on the console. These are, this is the output of the show gym observation utility and is showing you all the values you have in the observation output. As you can see, you have a frame, then you have a stage information, then you have information about the opponent character that is facing you. In this case, it's Zach. We are using Yan Li, and so this is our own character. Then there is the health of your opponent, your own health, your side and the opponent's side, wins and actions you performed in the previous step. So this is the list of observation available for this game. Okay, now one thing we can do, of course, this is going, as you can see, we are also printing out the reward function. And now here the episode is done. The info is showing you, it's providing you a dictionary here. So yeah, was another episode in the same game. Now let me edit this file. Okay, let's say that, for example, we want to use 128 frame, but in grayscale. So we need to add one here, and everything is explained in the documentation, in particular right here. As you will see, frame shape with all the description on the tables. Now let's say that we want hardcore false for this moment, but we want to change the game. For example, let's say we want Street Fighter. So the ID for Street Fighter is this one. So it's SF3I and 3N. And let's say that we want to use, for example, Ryu as a character. Since we were playing on P2, I need to prescribe Ryu on the right of this list. Now let's see if I'm not forgetting something. This should just load Street Fighter 3. And we will be using Ryu, and we will have a small frame of 128 times 128 in grayscale. These are all choices that you will need to do, to have when you are building your own agent, if to use RGB frames or colored ones, so or grayscale ones. Now, as you can see, now the frame is in grayscale here. And as you can see, Street Fighter comes with more information in terms of observation dictionary. As you can see, there is not only health values, characters used, but there is also, for example, the value of the bar used. Let me stop this so that the screen doesn't scroll down. As you can see, there is the stun bar, the super bar, which super type you selected during the game. So every game comes with his own specific RAM states, and you can again access them in the game specific page. On the documentation, as you can see, the observation space is described. In every screen there is an explanation of what's the observation, the RAM state for that game, and there is a screen where they are indicated, but also they are described in a given table down. So for example, there is the super bar is a box value, meaning that it goes from 0 to 128, and that's the value of the bar for your super move. So everything is described on the documentation. You can use that. You can decide, I think that knowing the health value and the super bar value, it's useful for my agent when I train it, so I will keep them. Otherwise, you can discard them. So this is a very quick overview of how to run agents with different settings, with different setups. An additional step. Let me do an additional step, because together, with those examples, you have the possibility to go and have an additional set of examples for wrappers. So what are wrappers? As I said, you have to decide which observations you want to use to train your environments. So your agent in your environments. Now, sometimes you just want to use the screen, and that's it. So in that case, you can do the following. You can say, you know what, I just need the screen, so I will set hardcore true. Now Okay, with hardcore true, if I restart the very same environment, let's see, it should run with only, without printing any specific information regarding the observation. Now, if all goes well, because these examples are tested for how they are and not for these changes. But as you can see now, everything is running and there is no information about, I don't know, side of the stage, health values, nothing. You only have the image. This is what our core means. It means that you only have the image and you will train only on the image. Let me stop again this one. Now, together with this option, you can have also additional modification to your observation space. Now, wrappers are, as they as the word say, are classes that wrap your environment and do high level modification on it. So for example, there are different wrappers and multiple operations that you can do. Let's go to the operation wrappers. Again, they are described in detail in the documentation, but for example, you can stack multiple frames because you may need dynamic information of the environment. So you may say, I don't want to use just the last frame, I want to use the last 4 frames, because I think that if I stack together 4 frames, I can recover some dynamics of the environment. I can understand towards where I'm moving, and so gather information about the velocity I have. So you may want to stack frames together, and so there is a dedicated wrapper that can allows you to do that. And this is the frame stacking wrapper. You may want to stack together multiple actions, for example, because you may say, oh, I don't want just the last action I sent. I'm interested in knowing, I don't know, the last 12 actions I sent, because if I want to perform a combo, in order to know how to do a combo, I need to carry with me the information regarding the last 6 button I pressed, for example. So there is a dedicated wrapper also for that. And there are additional ones. For example, you may need, this is a very important one, to scale your observation. So as I showed you, the observation are, for example, the screen pixels are between 0 and 255 values. The bar for Street Fighter was between 0 and 128. Maybe the stun bar goes between 0 and 72. So there are multiple values. The health bar can go from, for example, and these are all information you have, as you can see, for example, in the game specific page, you have here multiple things like information regarding the number of katas, the resolution of the game, the number of outfits you have, the number of the stages, but also you also have an information regarding, for example, health values. So for Street Fighter, the health value goes from -1 to 160. For Dead or Alive, the same thing goes from 0 to 208. So when using neural nets, as in deep reinforcement learning, one key point is to normalize inputs. This is a very important point. So this is what wrappers, scaling wrappers, are there for. So they are able to autonomously normalize properly all the observations we have, taking care of considering the lower and upper bounds of all the observation you have there automatically. And so this is another important wrapper. The same reasoning applies to the reward. Also reward, since, as we said, the reward is proportional to the health you are able, to the damage you're able to infer to the opponent or to the damage you suffer. Of course, these reward values depends on the game, depends on the, how strong the hit you received or you inferred was, in this sense, you need to normalize the reward too, and there is a normalization wrapper also for that. So there are multiple ones for to cover many different needs, and these are things that you may need to interface your environment with your agent. Now let's take a look at a very concrete example. Let me just copy here the wrapper example that you have online in DIAMBRA Arena GitHub examples. This is the very simple script. Let me just create a new script and paste this one here. So let's run it line by line. First of all, we import the DIAMBRA, and then we import the wrapper observation, rapid observation utility that allows us to print them on screen. So as you can see here, we are creating an additional dictionary, wrapper settings, and this dictionary is the one that activates different wrappers. As you can see, for example, here, we are resizing the frame 128 times 128 times 1. This means grayscale. So you may wonder, why are we doing that here in the wrapper while we can do that in the setting? Well, this is would be a good question. We added both the possibilities. So you may have the original, you can resize the original game frame inside the environment itself, or you can keep that as it is and resize it using a wrapper. It is up to you. Sometimes you may use the first one, in other case, the other one. This one is, so the first one I showed you is preferred because it's faster. This one adds an overhead on the Python side, while the other one is done in C++. So it's up to you depending on the use case. As you can see, we are activating the reward normalization here with a given normalization factor. Everything is, again, is in the documentation. We are stacking 4 frames together. So we are just, keeping all the last 4 frames. We are stacking 12 actions. So we are using the latest 12 actions together. We are scaling all the observations and so on and so forth. So there are multiple options here. Let me just comment out these 2 for now, because we don't need them at the moment, and I want to show you something else. So okay, let's run. As you can see, you just need to add the dictionary for the wrappers to the make command and then run it. This is it. So let's just run it. This should be it. And now we will run Dead or Alive with a wrapper. So we should see 4 different frames that we are stacking together. We will see 12 actions listed together, and we will see them normalized. Let's take a look at what will happen. So everything is starting, and let's see. Okay, as you can see, we have now 4 different frames. And I will, they are, as you can see, they are shifted by 1 step, one to the other. And now I can just stop. You can see them that they are slightly different. They are capturing the evolution in the environment. I can stop this to let you see. As you can see, actions are scrolling here because we are keeping the latest 12 of them. Let me just stop everything so that you can better take a look here with more clarity. So the actions are these 12 here, move actions, and these 12 here, attack actions. So you may wonder, why are they in this form? I mean, I would expect only 12 numbers. Well, the reason is that we are also applying scaling. This means that for categorical variables, we are applying the so-called one-hot encoding, a way in which we transform categorical variables from simple categories to vectors, as in this case. In fact, as you can see, the health value that for the other life goes from 0 to 208. Here it's normalized between 0 and 1. Same applies for the opponent, of course, and so on and so forth. So there are all these wrappers are operating on the observations, automatically to give you a proper normalization to make sure the input you will have you will give to your training script is properly treated to favor learning for deep neural nets. So we saw how to interact with the environment. We saw how to set up, to access different settings. We saw how to add wrappers. It's now time to move to interfacing our reinforcement learning library. Now, if you go in our documentation website and you click on hands-on reinforcement learning, there are two main sections. The first one is learning RL, and the other one is end-to-end RL. The first one points you towards those resources that I mentioned during our talk 2 days ago: books, courses, papers, some documentaries, very interesting. And then there is the end-to-end reinforcement learning. This is where what you learn is applied. So in particular, there are three main libraries mentioned. We will be using stable baselines. And at the very bottom here, there are two dedicated pages, one for stable baselines and the other one for array RL lib. So let's go to the stable baselines. And so here we'll see basic and advanced examples. The first one will the basic ones will allow us to build step by step very simple scripts. But to do that, the first thing we need to do is to install DIAMBRA, what we provide as a native interface with stable baselines. To do that, you can just, as you can see here, type pip install DIAMBRA Arena and add between square brackets stable dash baselines 3. Let me do that in live here with you. This will collect and install additional packages included, for example, Torch, and this will get your environment ready to be used, with stable baselines 3. This is all what it takes. If you already know that you need to use stable baselines 3, instead of doing what we did in the very first part in the installation, you can, at this passage here, you can just prescribe DIAMBRA Arena and stable baselines 3 between square brackets. That is all what it takes, and everything will be ready to use stable baselines 3. Now let's move on. The basic interface, the basic example, let me share it with you. This is, as you can see, very short, and we will just use it. Hopefully everything should go smooth, because the different version have been pinned to the ones that we are confident will work. And so once everything is done, it should be any moment now, I will start with this very simple. Okay, here we are. So the basic script for, and again, you have a reference for this in the documentation, the very first basic script. This is it. Before running, I will go through it step by step, but let me also say that if you go on our GitHub page and together with the repository for Arena, you find another repository that is called agents. In this repository, DIAMBRA agents, you find inside it multiple examples, and for example, for Ray or lib, but also for stable baselines 3. Those examples that we will be doing here today, you will find them all online. And of course, it's open, it's open source. So every single, for example, this basic example is here. And this is the one that we're going to use now. Now, very easily, as you can see, import DIAMBRA Arena from stable baselines 3, import A to C. That is one of the RL algorithm you may want to use. You create our Arena environment. And we are just, as you can see here, we are just prescribing our core and the frame shape. This is the setting dictionary that we already saw. And then we are ready to start training. This is, I mean, you don't need anything more than that. So you create the environment, and then you instantiate your agent with of type A to C with a convolutional neural network policy. This is the famous policy of the DQN, the very first successful application of deep reinforcement learning. And then you just prescribe, the agent to learn, in this case, for 200 steps. But of course, it's very short, but it's just for demonstration. And then you start the agent execution right away. I mean, when training is completed, you can use the very same loop that we used last time. There is only one big important difference, and this one. We were using random action previously. As you can see here, we are not using random action anymore. We are letting the agent predict the action based on the observation we are receiving from the environment. And this is the loop. So you, with the action predicted, you step the environment, you receive a new observation, and you go back to the prediction step. And this is it. So you train the algorithm and you execute it on the environment. So I can run this real quick. And it should be very simple. Again, DIAMBRA, run, Python, basic. This should be it. This should be, I mean, as I said, I never tested in this machine, and we'll see, of course, there is an error. Let's see, of course, there is a problem with protobuffer, but this is how I will show you a different version of it. This is how you execute this script. Now, let me move to a different context. I will show you the trained agent, and that is something that runs, I'm sure. Just before doing that, let's take a look at different options you have. So this basic example, as you saw, was just a very simple one, but there are multiple examples on our documentation. In particular, one that allows you, for example, to demonstrate you how to save and load an agent. How is it different, any different with respect to what we just saw? Well, as you can see here, let me try to zoom in a little bit. So we, again, instantiate the very same environment. We create the agent, we train it, and then we just add a save method here, and we reload it here. That's it. As you can see, after we save it, we delete the agent just to demonstrate loading. When we load it, we are ready to restart the very same interaction loop with the environment. Now, after that, there are multiple examples, but the most important one is at the end, is the training script that you can find online. And this is a comprehensive example showing you how to completely configure the script and the agent to run the entire training loop. In this case, for example, we are setting all the configuration using a YAML file. And this is an option, of course, but everything is, of course, available here. As you can see, when you prescribe different settings, you prescribe different wrapper settings, and you run the training as we did. Nothing different than training the agent agent.learn the number of time steps, and that's it. Now, the trained agent can then be run on the interaction loop. And in order to do that, let me shift to a different workspace where I have everything ready. Of course, our agents are our environments, as I said during our previous presentation, are sized in a way that you are able to train them at home. But of course, learning requires time. And for this reason, at least a few days are needed. And so we cannot do that right now. We cannot train an agent right now, but I will show you an agent that I trained in the past. And at the moment, we can take a look at it, and maybe at the same time we can take questions, because it will take a while for its execution. But let me just first run it. So I will need to update my credentials and then run this, and then finally run this. Okay, so everything is loading up, and soon we should have, okay, here is the native game interface. This is the screen that we will be using. Let me just drop down the, okay, this will allow us, okay, and now let me just open this one. Now you cannot hear the sound because it was sharing the screen is not able to share also the audio, but there is the original audio, and we will be using Dead or Alive, as you can see, and the trained agent will be using Kazumi. On the left, you see the user that submitted the agent. In this case, is me. The score in live. Now the screen will, as you can see, it started. Now you will see the reward, the action performed by the agent in the gamepad there. And at the same time, we will take a look at the total cumulative reward that we will be collecting. In this case, the score is 101, and it will be growing during the run. We are running 5 different episodes. This is usually 5 to 10 episodes is a standard amount to evaluate performances. And yes, the agent is running deep neural nets in real time to perform inference on the observation it receives. This has been trained using the screen, so screen pixels, plus a few additional RAM states like health values of both characters, side of the stage in which you are, the stage number in which you're playing, and more or less that's it. As you can see, the agent is pretty performant. One thing that I should mention in this regard is, if you remember how the random agent was behaving, the first things you notice here is how the train agent is less spammy, I would say. In fact, he waits for the opponent to come close, and also to stand up after being hit and lying on the ground. These are clear demonstration that the agent has learned how to proper time the attacks and how to defend too. Let's see, this should be stage 2, so we're moving to stage 3, I think. And yes, we'll see. This game has 8 different stages. Now usually the second last is the more complex. In fact, it's at least for this character. And usually if you reach the final stage, you usually complete the game. We'll see. But usually the 6th and the 5th stage are the most complex, especially when you face Yan Li at the 5th stage or 6th stage. Those are the more complex. Now, as I said, all the scripts that you have in our repositories are definitely open source and available for you to take inspiration and train your own environments easily, because what you have to do there is you can tweak a little bit the observation space, you can tweak a little bit the neural nets you want to use. You can also add some heuristics you want, maybe you want to add, but the logic is there. Now I'm using, in this one, I'm using the so-called proximal policy optimization algorithm in stable baselines, and that is one of the algorithms, or the best algorithms that are currently available. So again, you can also change that if you want. There are different multiple options in this regard. Now, as you can see, we are at stage 4. We won the first round. Let's see how it goes. This agent has been trained for more or less 2.5 days. This is what it takes to obtain these performances. That is definitely, I mean, not super quick, but also not impossible. Okay, we lost a round here. It's something happens. But one important thing is, as I already shared last time, these agents are not optimized for the round win. These agents are optimized for the maximum total cumulative reward. And this, since our reward is the health value, is based on the health value, they are maximizing the amount of health, the difference between the health the damage they cause. Oh, we lost this stage. So let's see, maybe in the next episode things will look better. Anyway, as you can see, we obtained the score of 830. And I can assure you that if you run a random agent, you go well below that level. Sometimes even with a negative total cumulative reward. We'll see if the second episode is a little bit more, competitive in terms of total cumulative reward, but you will find multiple examples of this also on our YouTube page. I don't know if Jousef, we may take questions in case people want to ask something. Let me just go down with the volume of the application, otherwise I won't be able to hear you. Okay.
I think we can take some questions. Yeah, very good timing. Any questions from the audience?
I'm not able to see the chat in case people are wondering if they could send them through the chat.
Yeah, feel free to ask Alessandro any questions. I'm wondering, Alessandro, is it possible maybe to do kind of a small homework? So basically people training their own agent and being able to fight against an agent that you've trained, for example.
Of course, it's possible, and that would be super, also very interesting. So the possibility, it's easily done by following all the, by starting from the examples I showed, and they're all available in the documentation. You can, starting from there, you can tweak a little bit the settings, in general, the algorithm, and in a few days, it is possible to have a good, a good performing agent trained. Of course, this is something that can be done even on CPU only machines. So, I mean, GPU is not strictly needed. Of course, the time will be a little bit longer, but it is definitely feasible. One important thing is though that multiple environments needs to be run in parallel. This is fundamental for this kind of technologies to have, you know, a varied experience. The agent needs to have a varied experience there, and so of course having multiple environments running in parallel at the same time is of paramount importance. Now, this is something that it's already, you know, available with our setup, and it's in our examples, it's already there. So definitely this can be something that people can use as an example, a starting example, and then tweak for depending on their needs. So yeah.
Really nice. If you could share that link, maybe we'll
Yes.
give the audience, like the participants, a small homework on training their own agent.
Of course, I can definitely prepare something. I will send it to you so that we can you can share it with the community easily. So I will prepare in you know, after the call, after the workshop, an email with all the details. That would be great.
Nice. Right. Any questions? We have 3 minutes left, guys, before we hop to the next session. Really nice tutorial, Alessandro. I think it was quite clear, very well explained.
Yeah, I mean, unfortunately, you know, these are things that require a lot of I don't know, incremental steps. So you cannot just skip ahead and go to the final step, because otherwise it's hard to get all the information in between. And so we had to rush a little bit. But as I said, all I was sharing today is on the documentation. So everyone interested in repeating the steps can definitely find everything there. So let's see if in these few minutes we have left, we're able to I don't know, go ahead in this experiment. But I think I think I'm probably using not the version that I trained for 2.5 days, maybe the one that was in the middle. For this reason, is not like winning every single stage, but anyway, you know, it doesn't add much. The concept here is this is a clearly trained agent that is performing his own good moves, and it's the very same applies. It's a matter of time. Sometimes, you know, you need just to wait a few days more, few hours, few days more to obtain a better performing agent. This is a standard thing. Yeah. As I said also in the RL talk 2 days ago, I'm more than happy to get in touch with the people participating in this workshop. There are multiple possibilities. There are all my references. You can reach out on LinkedIn, but also on our Discord server. That would also a good point to get in touch. We can provide support for installing the agents and running them. So definitely a good way to discuss. We are at stage 5. There are 8 stages of this game. Now let's see if we are able to reach at least one of the final, you know, the semi-final or the final one. You see there, you know, the agent is also performing counter moves, as you can see here. So these are all things that the agent learned during his own training process. And okay, we're reaching stage 6 now, and this is not easy. You know, Tina at stage 6, as Jan Lee at stage 6. They are strong opponents. So sometimes it's very complex. Now the opponent at stage 7 is always the same for Kazumi, and is Ayane, and it's another very complex one. And then at the end, the last character is usually the easiest if compared with 6th and 7th stage. Let's see. This is the 6th, round one. Jousef, you tell me if we want. We can stop now. No problem at all. And I mean, we will share videos maybe of the trained agent to the community. No problem.
Yeah, we can do that, and I'll also share the YouTube channel from you where you basically train it all from scratch.
Yes, exactly.
Yeah, that's pretty cool.
Okay, can you stop the screen if you want? I mean, it's there.
Yeah,
Okay. And this is reaching the semi-final at the moment. This is the hardest one. We'll see. Jana, it's the most complex to face. It's at some point in time you start looking at this. It's the good thing about these environments is that you have a way to measure the training in even from just looking at the agent performing in the environment, and this is good because you have a feedback. It's not just numerical values rolling in the screen. You may watch the behavior and I don't know, figure out what is going wrong with the training, maybe give a little bit more weight to a given specific feature, a specific observation, and so on. But okay, that was close, and this is 1-1 at the semi-last, semi-final. Not sure we're able to reach the final stage, but we'll see. And anyway, again, feel free to reach out. I'm happy to share guidance in using these environments. This is definitely great. So we reached the final stage now. Jousef, if you want, you can bet like 1 or 2 minutes. I think we could be able to finish the game in this run.
Let's see. Now I'm interested.
Yeah, I know. This is how it look. We'll see. Oh God. This is one of the first, worst starts in the final stage I saw so far. Usually it's way easier to beat the final character. But let's see, we have 2 more rounds. This is done, but 2 more rounds, it should be good. I mean, let's see. And depending on the game, training time can get longer. It depends. I mean, it depends on really on how the game behaves, what's the mechanics, even the proportion of characters with respect to the size of the stage. Because with big characters, it's easier like to hit the opponent and get those rewards that you need to learn. So, okay, now we are 1 round far from finishing the game with this environment, with this agent train. Let's see, all in 1 round.
They make me nervous.
And by the way, what you see on the left, my photo and those badges you see below, those are all things that you will be able to win on our platform. Well, okay, we did it. I'm happy. Nice. We managed to complete the game together. So yes, this is how, and this is just using stable baselines, nothing different. So let me just stop this sharing right now because we're already late. I want to respect all the time for the other presenters. So it was good. We managed to complete the game in live.
Really, really interesting. I was wondering maybe one last question before I wrap things up, Alessandro. What about shooters? It feels like if you use it for shooters, it might feel like a bit of cheating.
Oh, yeah, I see your point. Well, let me say that, first of all the RAM values we use here in complementing the screen are all, we call them fair RAM values, meaning that they are numerical values, but in health bars, you see them on the screen. So you can either way recover that number. And we would do the same with first-person shooter. We wouldn't allow the algorithm to use, I don't know, through the walls vision, I don't know. So it would be, I would train it, there are at least these 2 things: fair values, fair observation spaces, 1. And the second one, the reaction time. You need to enforce a human meaningful reaction time there, because it's superhuman reaction times. It's of course not fair. And these are things, for example, the agent you saw was performing actions at, a maximum of 10 actions per second. And this is pretty in line with with what a human can do. for example. So, and the maximum could be 60 actions per second. An agent can be trained to send 60 actions per second, but I on purpose trained it with 10 actions per second to make it more, human, fair to humans. This is the reason. So
yeah, I see. I think they did the same thing with the OpenAI 5 versus 5, because the reaction times were superhuman, and then they just tweaked this parameter.
Yes, exactly. Yeah.
I
Of
thought,
course, it's very important to make it fair if you want to have human versus AI competitions. Definitely important. Yeah.
Really cool. Really enjoyed it, Alessandro. Thank you so much.
Thank
Feel free
you.
to forward us the resources, and also maybe for small homework if people want to train their own agent.
Perfect. Of course. Can you confirm you received the presentation?
Yes, I did.
Okay, perfect. So that is there, and I will add all the information we need for the training the agent. Definitely.
Sweet. Awesome, Alessandro. Thank you so much, mate, and hope to see you soon.
Thank you. Thank you, Jousef. Talk soon. Bye-bye.
Bye-bye.
Bye, everyone.